and a quick introduction to Classiq, to position it within our trajectory. We did just hear about the importance of these two areas, the hybrid computing and also the generation of circuits on the heat maps we just saw. And so this follows on, I think, very nicely from exactly those points. Classiq is a company that is a leading software company. We're focused precisely on that area of generation of the circuits themselves. And the focus that we have is on really doing all of the heavy lifting and automating and generating those circuits. This is why we're so fortunate and would like to say thank you to many of our partners, not least of whom, of course, are HPE, from whom you'll be hearing in the second part of this talk on the conversation. So we're really focused on a couple of things. You'll see on the slide on the screen, on the left, what we want to do is help you to minimize the manual. You'll see in this whole process of arriving at an implementable circuit that today most things have to be done manually. Under the Classiq approach, you keep the manual to a minimum, and we essentially amplify the automation. This means that rather than having to review your circuit every time your conditions change, every time the constraints of the hardware change, you're able to regenerate should there be any change, but you might also want to optimize for different things, different depths of circuit, etc. So we allow you to automate all of these things, but it's also done in a hardware agnostic way. And that's absolutely crucial when it comes to making the most, not just of quantum, but also in the future of making the most of hybrid as well. That agnosticity is absolutely crucial. This means that using our platform, you have the access to various libraries of functions, but also the opportunity to develop IP. We work with enterprise customers on all kinds of vertical-specific issues. Some of these are baked into the platform. Some of these are very advanced developments of customers working on questions that perhaps haven't been tackled before. For example, you can see here CFD over on the right is a project we're currently doing with Rolls-Royce. But of course, we're open to all kinds of approaches on esoteric questions, but you're able to review and iterate and develop large or complex circuits really at the hit of a button. The other component, once you have your circuit generated, obviously based on that model that one puts most of the work into, is the ability to connect to the hardware itself. So our output is agnostic. We're able then to essentially make the most of the optimization capabilities at the functional level before one moves on into the compilation, which has somewhat more limited optimization capabilities. And a recent announcement we had with Microsoft looked at us doing exactly this, taking a very chewy problem of making Shor's algorithm implementable and actually taking it all the way through our process and estimating what kind of hardware we would actually need for that to be feasible. It's not just for academic papers, of course. This holds for any kind of enterprise-type implementation as well. If one's looking to explore very large, very complex circuits, even working on IP that will hold in the future, this is an absolutely crucial component. So this gives us a little bit of a basis to perhaps do what we saw the industry itself is doing. Begin to start taking the steps out of what is perhaps quantum exploration, where the focus is on POCs, on getting to grips with the fundamentals of the approach, looking at perhaps simpler types of simulations, and thinking about how does one move on from here. And we see this with certain enterprise customers who are looking to take it into a much more production-type environment. So with our platform, we essentially have our new motto, which is really that the circuit is something that is a result of whatever you happen to have access to in terms of which type of hardware at any given time or which supplier of hardware. But the focus is that that model should be something that survives any kind of implementation and can be optimized for those different types of hardware. In order to move into production, and I think we're all seeing this, it's an issue of leveraging hybrid approaches as much as possible. We saw the importance of error correction. We see the importance of circuit efficiencies. We see the importance of schemes that allow you to combine the different types of hardware to make sure that quantum is doing what it's best at and that the classical side of things is doing what it is best at. And that is why we're so happy and glad to be collaborating with HPE on precisely this. So we're looking now at how to integrate our entire flow from that initial setup and focus on the model and the constraints through to hardware agnostic output. Also, courtesy of our collaboration with Q Control, you'll see there adding in error corrections so that one can really make the most of the quantum schemes, but adding HPC into that capability, giving one cloud access from the point of circuit generation all the way through to compute, whether that would be classical or quantum. And this is exactly the combination of these two stacks that we're working on together with our partners at HPE. And I'd like to introduce Kirk to perhaps step in and speak on the point.
Thank you, Simon. Thank you for inviting us to have this conversation today. I really appreciate it. And actually, I've been bouncing up and down the peninsula. I spent this morning up in San Francisco with the IEDM and the IEEE conferences. And I think one of the things that's there is think about all that semiconductor expertise. And it wasn't just about the expertise. It was about a global community coming together to solve really hard technology problems, really hard business problems, and part of what that has made that all possible is that roadmap. You know, it was started with Gordon Moore plotting out a couple points, the minimum number of points to define exponential growth, but then all of that global community coming together to solve the problems and then to make it real. And really, that's part of what we were so attracted to about being part of this community. And we do have a little bit of history at Hewlett Packard Labs in quantum. We had a team 10 years ago that was doing nitrogen vacancies on Diamond as their qubit modality, and that team actually decided to put that work. They wrote up their papers, they put the work on the shelf, they pivoted to become our large-scale integrated silicon photonics team. And part of the reason that back then that they stepped away from the work was Hewlett Packard Labs is rooted in the problems of our customers and enterprise customers 10 years ago. This wasn't on their radar. Flash forward now 10 years hence, and with the acquisition of both SGI and especially with Cray, creating the world's most powerful classical hybrid heterogeneous supercomputers, we now have a lot more customers that are coming, and certainly because this is the Q2B conference, you all know as well. It is much more about enterprise and working finally from the problems down. And I think that was part of what we saw was so attractive with the potential to work with Classiq, having someone who occupies that middle space. And certainly for me, as an electrical engineer who toiled his way through that basic semiconductor physics class, my last quarter at Santa Clara University, even though I had the job at HP, I still had to get past that one last class. And of course, I didn't need to know any of it, because at the time I got to the point where I needed to design that chip, the tool vendors had already taken care of all of the hardware. I could concentrate on the logic, I could concentrate on the business outcome, and someone was sitting there who had worked out the relationships, all the information, the optimization, that ability for me to engineer in the way that I was comfortable, and then still let all the other elements of the stack really live up to their potential as well. And so that's why when our venture team from Pathfinder tapped us at the labs on the shoulder and said, hey, what do you think about this company? It was like, oh yeah, we were very bullish, and remain bullish not only on the investment, but also on the partnership of technology. So thinking about, for us, and I'm going to skip over the pretty slide, to get down to the meat of, like, what are we doing at Lab? So, we're not going to go and dust off that 10-year-old NV Center work. There's lots of very clever people working on that, as well as all those other modalities that you could see in that hall right over there. What we really want to understand is what can we bring that's unique to this conversation? And for me, that's an element of integration and scale. Whether it is integration at the physical level. We just turned on the world's fastest supercomputer at Oak Ridge National Labs, and by the way, that means doing things like engineering a rack of equipment that can consume and then cool 100,000 kilowatts, 100 kilowatts inside of one rack. That physical integration, the work we've done with teams like Cerebras, the wafer scale integrator, understanding how we integrate this incredibly performant platform at the cyber physical scale, and finally at that all-important productivity scale. How do we take the subject matter experts today who want to have this efficiency, who need to have this capability, and make it accessible? And for us, that is a partnership. And so we're looking at three buckets that we're really going to focus on in terms of our contribution into this global community. I'll start on my right there. The quantum-inspired accelerators. As I said, we had we had some qubit research. The team pivoted to work on large-scale integrated photonics. So important in the energy-efficient transport of data, whether that is from chip to chip, aisle to aisle, or shore to shore. Now that team, having completed a lot of their work and beginning to land it at foundries at different places around the world, they're actually going to take that same technology and pivot back again towards computation in quantum-inspired areas, in areas that we anticipate quantum will provide advantage. They're going to see if they can do a parallel path. Now, this isn't to shade on the quantum expertise and the capability, but we need to try to learn as much as we can, as quickly as we can, to connect enterprise into this solving engine. And for us, this is a parallel path, and we'll give that software team and all the software communities yet another way for them to begin to connect real enterprise problems with real computational efficiency. On the other side of the spectrum, a unified workflow environment. Today we think of you think of that supercomputer data center, you probably think about simulation modeling. And yes, it's that, but it is also massive data analytics, it is also AI and ML, and it is no longer confined to that supercomputing data center. Fully half of the applications we anticipate running in that exascale will end up pulling their data from global sources. It is already an edge to exascale world, and being able to create and pull together novel workflows where edge, exascale, instrument science, and massive capabilities of analytic power from quantum-inspired, and other heterogeneous compute, we need to understand how we will create those. And again, this is where I think that community discussion, what is it like to host a quantum-inspired? What is it like to host any of the half a dozen quantum modalities? What is it like to have that right next to next-generation AI accelerators? Understanding how we make all that productive, I think that's the second piece that we really want to contribute. And the final piece is in the middle there, and it is that large-scale simulation. And that is, how do we take the world's highest performing classical computational environments and do two things with them. One is make them available and accessible to everyone who really is doing the hard engineering and physics of making quantum accelerators real. And I think that ability for us to create that environment, to hold up those simulations, to partner and to go head-to-head, constantly raising the bar on classical algorithms, but also supporting the engineering and science of quantum computation is an important thing. And the second piece is that when we imagine that first, really advantageous solution, we think it won't be anyone's pure play. It will have quantum acceleration. It will have AI, and it may not be that it's just one workload and then passing off to a second workload. It may be that if we really want to have that breakthrough in the cyber-physical control system of quantum, we will need that massive AI accelerator, inferencing, controlling that quantum environment with superhuman precision, and that hybrid environment, making the quantum behave better, make it more productive, making it more precise, higher efficiency, lower error rates, all of that plumbing together, and the massive data flows in this hybrid environment, I think that's also what we want to pull together. So understanding how we create tomorrow's supercomputing workflows, hosted from edge to exascale, augmented with all of these advanced accelerators, is what we really want to lean into. And what will only matter, it will only be a beneficial outcome if from the very top, from the problem, all the way down to the modalities, we can stitch all these pieces together. And that is not just a bunch of individual efforts, that is a global co-design effort. And so much of that will be this next generation of software. And frankly, a lot of that software will probably not be written exclusively by humans. But again, that machine learning, that AI augmentation of the physical operation, of the software generation, of the control, and finally the capitalization of these systems is something we think is really promising. And that's why for us it's a great labs problem, but it's a great problem for us all to be able to contribute to. So with that, I want to thank our partners at Classiq again for coming us and inviting us to talk today. And if there's anything more that you'd like to learn from either of us about this, this is certainly an open area for collaboration. Thank you.